My student, after that short break, let us proceed. After defining what is wavelength, now we are going to treat wavelengths in terms of mathematical operations. Now let us come here. Let us come here and we can have a simple illustration. We said, remember, for you to get wavelengths, the x-axis must be distance, because wavelengths is the distance, not time. Make sure the x-axis must be distance. Therefore, the distance for a complete one cycle, this is half of the cycle, this is half of the cycle, therefore this is one cycle. Therefore, if we're told this is maybe 1 centimeter and this is 2 meter, here wavelengths, the answer is 2 meter. Why? Because wavelengths is the distance for complete one cycle. This is the distance which a one cycle has been completed. Now this one can be look very simple. What if I have many cycles, not only one cycle, I have many cycles. What am I going to do? What am I going to do if I have many cycles? For example, can plot here. We can have this one here. 1. This is a half cycle. I have many cycle. And this cycle, they're at a distance. This cycle, they're at a distance, let's say x. How many cycles do I have here? I have 2.5 cycles. 2.5 cycles. Remember, the distance given may be x can be maybe 10 meter. The distance given can be 10 meter. This distance is for completing 2.5 cycles. What did we say about wavelengths? The distance between one cycle, this one here. But what we have here is the distance for 2.5 cycles. And you have been asked to calculate wavelengths from 2.5 cycles with a distance of 10 meter. This is very simple. Under these situations, wavelengths will be calculated by taking the distance traveled, which is x, you divide by the number of cycles completed in this distance, which is n. Therefore, for example here, our wavelengths will be equals to 10 meter. You divide by the number of cycles, 2.5. 10 meter, you divide by 2.5. The answer which you will get will represent wavelengths. 10 divided by 2.5 number of cycles. Therefore, wavelength is 4. Wavelength is 4 meter. Therefore, from this point to this point, which is wavelength, is 4 meter. This is the simple way of calculating wavelengths. If we have many cycles, just take the distance traveled by those cycles, divide by the number of the cycles. That is one. Second, it is also very simple to calculate wavelengths if at all you have been given crest. It is very simple. It is very simple to calculate wavelengths if at all you have been given crests. For example here. For example, this one here. For example, this one here. I have this one, this one, this one, this one again. Okay, let me go to the second for trough. If I have two crests, that means the distance between these two is what we call wavelength. For example, if this is maybe 2 and this is 4, the distance between these two is 4 minus 2, which is now wavelength will be equals to 2 meter. This is very simple. The same like if this is now 3 and this is 5 here, the distance between 5 and 3 for the trough is 2, which is now wavelength is 2 meter. Now what if I have more than 2 crests? I have many crests, or I have many troughs, or I have many compressions, I have many layer functions. How can I calculate wavelengths? This is only if I have 2. What if I have a large number of crests, more than 2? Look here. Wavelengths, if we're told you have more crests, maybe 10 crests, or 15 crests, 20 crests, wavelengths will be calculated by taking the distance traveled by the crest. Look here, for example, can assume, let's assume here number of crests. How many crests do we have? 1, 2, 3, 4, 5. I have 5 crests. Therefore, what the distance between this crest? You should know the distance between this crest, which is now given by x. You divide by, if you at all you have many number of crests, or trough, or compression, or layer function, you take the distance between them, you divide by the number of those crests, or trough, or compression, or whatever, any, minus 1. Minus 1. We can prove this formula if it's correct. Assume n is 2. That means I have 2 adjacent crests. When I have 2 adjacent crests, when I substitute here, I'll get x over 2 minus 1. The answer is x over 1, which is equal to x. Now this answer tells us what? This answer tells us that wavelength is equal to x. Wavelength is, what is x? X is the distance between what? Crest, trough, or compression layer function, or whichever feature. Therefore, wavelength is equal to x. X was the distance between 2 adjacent crests which agree from the formula. If you are told you have many number of crests, many number of trough, many number of compression, many number of layer function, the formula to use is wavelength equals to x, the wavelength, the distance given, over n minus 1. I think we're going to look at the examples. Now let us go to the last approach here. Now this approach is saying, what if now, instead of having crest or trough, I'm having things like this one. I have only crest and trough. I have only crest and trough. Therefore, you have only the distance from crest to trough, which is this one here. The distance from crest to trough. Crest to trough. You have only the distance, not from equilibrium position, no. From a peak to a depressed area. The distance from crest to trough is x. And from here, you have been required to find wavelengths. Now, if we are told you have been given the distance between crest and trough, and you're required to find wavelengths, look here. Look here. Wavelengths will be equal to twice of the distance given. Now, if you have been given the distance between crest and trough, or compression layer functions, for you to find wavelengths, you are going to take twice of that distance to get wavelengths. I think that is well understood. Therefore, we have two concepts. We have three concepts. One, if at all I have many cycles, wavelength is given by the distance which makes the cycle over any. If at all I have a many number of crest, trough, compression, whatever, wavelength is nothing but x over n minus 1. If at all I have the distance between crest and compression, that means crest and the followed the next trough, crest and the next trough, wavelength will be nothing but twice of that distance. Therefore, make sure this formula they are at your peak of your hands for you to remember. This one is very useful. This is most useful, and you'll be asked so many questions concerning about this formula as wavelength is concerned. Therefore, my friend, we can now proceed by looking simple things as wavelength. Wavelength is not constant. Yesterday, on the last period, we saw that frequency is the constant because it depend on a source. But wavelength is not constant. Why? Because now wavelength depends on the medium of which the wave travel. Therefore, if the wave moves from air to maybe water, waves will change from that wavelengths will change from that of air to that which will be underwater. Therefore, why? Because wavelengths depend on the medium. Therefore, wavelength is not constant. Wavelength is represented by a Greek word, a Greek symbol. This one. Now, this one we call it lambda. Lambda. Lambda is a Greek name which represents wavelength, and this is the symbol of it. And the SI unit of wavelength is meter. Why meter? Because wavelength is the distance. Is the distance. Is the what? Is the distance. Now, my friend, at that point, let us have a short break. After that short break, we're going to proceed with examples on how we can calculate wavelengths.